The Great Oxidation Event is one of the most important moments in Earth's history. A reign that had lasted 180 million years was abruptly ended by a devastating asteroid collision. Massive amounts of debris were thrown into the air by the crash that killed the dinosaurs, and portions of the American continents were washed away by enormous tidal waves. The entire living world was altered. What was the Great Oxidation Event, and when did it occur? Did an asteroid wipe out the dinosaurs? And how big was that asteroid that wiped out the dinosaurs? Join us as we explore the science and history behind this incredible time in history. The history of life and the planet itself is recorded in the rocks all around the world. Rocks are stacked on top of one another, and fossils of all sizes are embedded in these layers, which are now visible at the surface. Paleontologists have the ability to travel back in time. Rock layers all over the world date back approximately 66 million years, preserving a remarkable transition from a world ruled by giants to one reeling from their abrupt disappearance. The rock layers older than 66 million years are represented by the Cretaceous period. The Cretaceous rock strata and fossils are a blast from the past, but they offer priceless insights into the prehistoric world. The improbably huge fossils, which are the remains of improbably gigantic creatures that roamed the land's surface and ocean depths, can be found in the third and last period of the dinosaurs. A radically different story is revealed by rocks that are less than 66 million years old. The number and size of fossils are drastically reduced here at the start of the Paleogene. They depict a world utterly devoid of giants and dinosaurs. In this new universe, there are no four-legged animals that weigh more than 25 kilograms. Most of them are small, including our own ancestors. Only 25% of the Cretaceous species still exist in this quiet, empty world. The Cretaceous-Paleogene boundary can be seen here, an Armageddon marked in stone, a line between realms that has been frozen. What exactly is the Alvarez hypothesis? A big asteroid hitting Earth in the past would have produced a layer of clay rich in iridium, according to a theory put forth in 1980 by Nobel Prize-winning physicist Luis Walter Alvarez and his geologist son Walter. The Alvarez hypothesis is a metaphor for how harsh life can be on Earth. They had extracted and studied a sample of the Cretaceous-Paleogene boundary in the Italian Apennines in 1979 using a hammer and chisel. One half of the first sized rock dates to the time of the dinosaurs, while the other half is from the era of tiny mammals. The only trace of the terrible event that had put an end to the dinosaurs' dominion could be seen running through its center as a fine, dark wavering thread. Walter and Luis found elevated quantities of iridium, an extremely uncommon metal on Earth, in that thin layer which, according to their theory, an asteroid delivered. An asteroid 80 kilometers wide struck the Yucatan Peninsula in Mexico 66 million years ago, destroying itself in the process and covering the entire planet with a thin layer of iridium. It set off a series of disastrous geological, climatic, and environmental events that in under 30,000 years wiped out all life on Earth. 75% of all species on Earth perished, including dinosaurs, never to be seen again. Luis Alvarez deduced the disappearance of the dinosaurs. How did a rock crashing into the Central American coast trigger this global mass extinction? The asteroid hit a high velocity and vaporized, Paul explains. There was complete destruction in the nearby area since it created a massive crater. A massive blast wave and heat wave were released, both of which launched enormous amounts of debris into the atmosphere. A catastrophic chain of events followed. It caused soot to spread throughout the entire world. Although the sun was not entirely blocked out, it did lessen the amount of light that reached the Earth's surface. There are still many unanswered questions. However, it was a major event that had an impact on every form of life on Earth, from microscopic organisms to dinosaurs. The list of casualties is long. Ammonites, a few microscopic plankton, and massive marine reptiles all died out. However, the loss paved the way for the beginnings of the modern world. Unfortunately for the dinosaurs, it was not enough to counteract the cooling, but fortunately for us, it might have been enough to let mammals inherit and eventually take over the Earth. What do you think about the Great Oxidation Event's impact on the evolution of life on Earth? Is it good or bad? Comment below.